Hi, I'm Dr. Chad Larson. Thanks for joining me in another episode of Keep It Real. As you know from the past couple episodes, I've launched a new program called the Keto Med Project. And in those last couple episodes, I talked about some of the details about the Keto Med Project, why we came up with it, and what we're really trying to do with the human body. At the basic root of it is we know that we're suffering from an epidemic of what we call overfat. Overfat is pretty much a different definition from being overweight and obese. Those are based on the weight scale. Those are based on BMI, body mass index. We're really interested in body composition, and a very simple way to measure that is your waist to height circumference. And you want your waist to be less than half the length of your height. So in other words, if you're 70 inches tall, you want your waist, which is measured around the level of your belly button, just with a flexible, tape measure, you want that to be 35 inches or less. And so in other words, if your waist is 36 inches and your height is 70, that would be a ratio of 0.51, and that would be considered overfat. And this is really what this program is aimed toward, but it's so much more than that. I want to sort of spotlight something today that's kind of at the root and kind of the common factor between all the different health benefits that you get from the Keto Med Project. And that is to spotlight the mitochondria. The mitochondria are the little batteries in all of our cells that charge the cells and give it energy. And the mitochondria produce a really important fuel called adenosine triphosphate, ATP. And ATP really is at the root of the energetics of our cells. If the energetics of our cells suffer, then disease follows. And so the health of the mitochondria is absolutely paramount and foundational to our normal general health. And so just to mention a few things about the mitochondria, like I said, are these little batteries in all of our cells, and they require some building blocks for the body to make ATP. And to keep it simple, there's two main building blocks, glucose and fat. And in some cells, fats require a conversion by the liver into something called ketones. Like your brain can't really use fat as fuel, at least fat from other parts of the body kind of going up to the brain. It doesn't work that way. Fat doesn't cross the blood-brain barrier, but ketones do. So your liver makes these ketones. A state of ketosis is basically when we have increased our production of ketones. And in kind of a technical sense, if you do a blood test, even just a finger stick test, you want your ketones to be at 0.5 millimolar or higher to be considered in a state of ketosis. And so this means that the body has started to use a different fuel source, fat in ketones instead of glucose. And so the mitochondria can work on fat, ketones, and glucose as kind of the building block for your mitochondria to produce ATP, this really important fuel source that kind of helps to keep everything going. And so here's what happens oftentimes at the beginning of sort of disease onset. Let's pick on a really common one, an increasing one, and one that everybody should be working hard to avoid, which is diabetes. Kind of the precursor to diabetes is called insulin resistance. And so when we talk about insulin resistance, what we're talking about is these cells start to become resistant to the effects of insulin. Remember, insulin gets stimulated, it gets produced when glucose goes up. Glucose goes up from consuming carbohydrates and other types of foods, and the glucose cannot get into the cell all by itself. Insulin is the key that opens up the lock so that glucose could flow in. But here's where the problem manifests, is that glucose is not supposed to be consumed and utilized at the levels that it does in our culture. And it's now being so highly overused that the body's kind of rebelling against it, because when glucose is the primary source of fuel for your mitochondria, it produces this inflammatory substance called reactive oxygen species, which produces something called a superoxide. And the superoxide is inflammatory. and it produces an enzyme that tries to buffer or kind of decrease the amount of superoxide. It's called superoxide dismutase. We call it SOD. SOD works like an antioxidant to try to bring those free radical inflammatory chemicals down. But as SOD goes up, that signals to the cell to stop accepting insulin, to kind of block that key from going into the lock. But as you know, what happens over time, if the insulin doesn't open up the lock, then glucose is going to go higher, higher, higher in the bloodstream, and then we start to get into insulin resistance. So the only and ultimate way of improving insulin resistance and decreasing or avoiding diabetes is to bring insulin down. The only way to really bring insulin down is to bring the carbohydrates down. So that's a really key component of the Keto Med Project, is to decrease the amount of carbohydrate coming into the system to allow insulin to kind of chill out. Because in this very short period of time of just consuming, more carbohydrate than what you as an individual can tolerate, could really accelerate this problem of insulin resistance and this whole kind of inflammatory process, which is sort of a byproduct of glucose metabolism. In that same respect, this has also been found in neurodegeneration, in dementia, and Alzheimer's disease. And what happens is, in fact, some researchers call Alzheimer's disease diabetes type 3. There's type 1, which is an autoimmune problem where the pancreas stops making insulin. That's different than type 2 diabetes, which is what we're kind of talking about with the whole insulin resistance thing. And then type 3, it's not technically type 3 diabetes, but what they mean by that is the neurons of the brain stop being able to utilize glucose for some of the same reasons. The body has this mechanism that's saying, hey, we have so much of this inflammation building up from using glucose over and over and over and over again. The mechanism to take up glucose becomes kind of malfunctions, and it just doesn't work right. So the Keto Med Project diet includes the right ratio of foods to help reverse this process that's happening. Also, cancer cells are very different from your healthy cells. Your cancer cells are dependent upon glycolysis, which is a sugar-based kind of energy system. And they do not have the metabolic or mitochondrial flexibility that your healthy cells have. Remember, your healthy cells can use ketones and fats and sugar, but cancer cells are abnormal and they can only really use glucose. So if we induce a certain state of ketosis, that will kind of starve the mitochondria of the cancer cells from proliferating. So if we could induce and lengthen our periods of ketosis, which is really what is instructed in the Keto Med Project, then that will help to kind of starve abnormal cell growth because they don't have the metabolic flexibility to live on ketones that they do sugar. So these are just a few things I wanted to mention about ketones and ketosis, and most importantly, the importance of the health and function of the mitochondria. So hopefully that was useful. I'm going to keep reading the studies. I'm going to keep putting this information into practical use and bringing you the information. Until then, keep it real.